Hi guys, and welcome to this, our 2021 VCAA Further Maths Paper 1 Solutions Walkthrough. Number 1, let me just say that these are my solutions and I'm fairly sure all of them are correct. If you believe that there are errata, do me a favour and let me know by making a comment below. I'll go back and check, and if there is an errata, I will actually place them in the comment section. All right, you can find all these solutions on mathsguru.com for all past papers. So hopefully you did really well in this exam if you just sat it, or if you looked at it as a past paper, fingers crossed you have smashed it. If you can do me a favor, please, and like this video. YouTube now works on likes, weirdly, and if you can subscribe, it just lets me know you've watched. Turn off notifications, you'll never hear from me again, but at least I know that you've watched the video. Right, I'm going to work through the course solutions first, and then I'm going to go through each of the modules, and I will do all 4 of the modules. Where possible, I will also cut down a lot of the calculator stuff just to keep the video shorter. But if any time you want to go, or how did you get that? Again, just leave me a comment below and I will do what I can to be able to answer that. Right, section A. So this was the core section, data analysis. First question was lovely. Percentage segmented bar chart below shows you ages of visitors of a travel convention segmented by preference. Question 1, the variables age and preferred travel destination are both. Well, age here is categorical. Travel destination, domestic and international, is also categorical. And then normally you would, so these questions tend to then go, well, is it ordinal or nominal or whatever else? But they didn't ask that type of question. They just wanted to know. And so as far as I'm concerned, A was my correct answer. The data displayed in the percentage segmented bar chart supports the contention, so we're looking for an association, that there is an association between the preferred travel destination and age because. Now remember, when you are relating this, you should be looking at including statistics as well as some sort of indication of why there is. So when I look through this answer, more visitors favour international travel, no. All right, it doesn't make any reference to both statistics. We've got to have statistics for both preferred travel destination and age. 35% of visitors, there's only one statistic. Likewise for C. So those 3 answers can be discounted straight away. Let's look at D and E. The percentage of visitors who prefer domestic travel is greater than the percentage of visitors who prefer international travel. Close, but there's no reference to any of my statistics. So 65% of visitors under 55 favour domestic travel, while 44 and over favour. Now to me, D I think is the closest answer. I would have preferred it if they'd had some sort of increase or decrease, because that's what we tell you guys to do, but I'm going to go that D is the correct answer. Question number 3 isn't all going to fit on my screen, sadly, but the results could also be summarized in a 2-way frequency table. Which one of the following frequency tables could match the percentage segmented bar chart? So what I did then was I said, well, okay, let's take this 91 here and let's divide it by 140. So when I do 91 divided by 140 and turn it into 100, because again, these are the raw values. These weren't percentages. They were actually the raw values. And so remember, you would have to convert them. When I did 91 divided by 140 times by 100, it gave me 64%. All right, so roughly 65%. If I look there at domestic under 55, so if we scroll back to my diagram of domestic under 55, well, if we look at that, it goes from 35 to 100, or probably just below that 35, and in which case that there is the 65. There was no point checking any of the others. I quite like this question because if you notice for B, there were 65, 35, 50, and 71. So if we look at all of those values there, well, basically that was the only one that fit. So A for question 3. The box plots below show the distribution of the length of fish caught in 2 different ponds, Pond A and Pond B. Based on the box plots above, it can be said that, all right, so when you went through all of this, 50% of the fish caught in Pond A are the same length as the fish caught in Pond B. 50% of the, no, that doesn't even make any sense, all right? We don't actually have lengths. B, 50% of the fish caught in Pond B are longer than all of the fish. So if I look at Pond B, there is 50% of my data below, and there is 50% of my data above. And as it turns out, my longest fish for Pond A was actually there. And so I state that B is the correct answer. And if you work through the rest, 50% of the fish caught in pond B are shorter than all of the fish in pond A. Nope. 75% of the fish caught in pond A are shorter than all of the fish in pond B. So 75% are shorter than all of the fish. And again, that's what you went through. They were testing that 25%, 50%, 75% rule. And so B, correct answer. The stem plot below shows the height in centimeters of 20 players in a junior football team. A player with height 179 is considered an outlier because 179 centimeters is greater than. That just wanted you to find the upper fence. So my upper fence is given by my upper quartile plus 1.5 times the IQR. So obviously I've got to find my upper quartile and my lower quartile. There are 20 data items. So if I do 20 plus 1 gives me 21 divided by 2, which is 10.5. So what I'm looking for is my data item between the 10th and 11th term. That's the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my median is there, which means I now cut each of those into halves. 10 items, 11, that's between the 5th and the 6th. 1, 2, 3, 4, 5. So that's between there. So I'm going to write down that my lower quartile is 148. And then 1, 2, 3, 4, 5 puts my value there, which is it's halfway between 158 and 160, which is 159. So that's my upper quartile now. So this value here is my upper quartile, which becomes 159 plus 1.5 times my interquartile range. How do we find that? We simply subtract those, which gives me 11. And when I do 159 plus 1.5 times 11, I get the correct answer of E, which is 175.5. So any values over 175.5 will be considered outliers. The relationship between resting pulse rate in beats per minute and age group is best displayed using. So what have we got here? Age group is categorical and resting pulse rate will be numerical. Now again, when you cross through all of these, scatter plot, note because it's two numericals, back to black stem plot is numerical and categorical, but two sets of numerical data, and that's no good to me. All right, so yep, a time series plot, nope. A histogram, nope. So basically when you go through each of these, and again, if you've got this in your summary book, there is a chart that tells you which are the best ones to use. I put C as my correct answer. 800 participants auditioned for a stage musical. Ka-ching! Each participant was required to complete a series of ability tests for which they receive an overall score. The overall scores were approximately normally distributed. Marvelous. So when I do normally distributed, I always draw the normal curve. I tend to put on my mean, which was 69.5, and a standard deviation of 6.5. All right, so then I tend to draw 1, 2, 3, 1, 2, 3, and I will write on my values. So 69.5, 76. Well, I didn't need to go any further because the question then said only the participants who scored at least 76 points in the audition were considered successful. So those people there were actually successful. But the question was tricked because it said using the rule, how many of the participants were considered unsuccessful. So actually, we wanted this percentage here. Well, I know that that's 50%. I know that that section there is 34%. So I wanted 84% of the participants, which was 800. So when I did 84 divided by 100 times by 800, it gave me 672. So I suggest for question 7D is the correct answer. To be offered a leading role, participants must achieve a standardized score of 1. So when I saw a standardized score, Z is equal to X minus mu on sigma. Well, if you remember, we know what the value of mu is. The value of mu was 69.5. Sigma was equal to 6.5. So what you then wanted to do was take each of the overall scores, these then became my values of X, and worked out the Z scores. And again, just to keep these slower, or I'll do the first one. So let's see, oops, Daisy, I keep hitting the wrong keys, bear with me. So that one there would be X, my original data would be 81.5, I would take away from that mu of 69.5 and divide by sigma, which was 6.5, and that gave me a value of about 1.85. So my Z score for there was 1.85. When I continued, Brian worked out to be 1.69, and Sherry 1.92. So we now know that Amy and Sherry will be offered leading role places. So which of the following statements is true? Well, as it turns out, C, that Brian was not offered a leading role, was the correct answer. And I was reading on Reddit recently that a lot of people quite like the exam, but they thought the questions were asked in a bit of a strange way. It's just testing your understanding of the question, all right? It's not just a regurgitation, sadly. Further Maths is about you understanding the work. The heights of females living in a small country town are normally distributed. So once again, I drew a normal curve. There we go. We knew that 16% of the females, I'm going to draw on my 3 sections here, 1, 2, 3. So it told me 16% of the females were more than 160 centimeters tall. So I now know that that line there, because that's 16% of my data, is 160. What next? 2.5% of the females are less than. So I know that that area there is 2.5%, 115. How does that help me? Well, I now know how to find a standard deviation because I've got 1, 2, 3 standard deviations, or 3 deviations, fall between 160 and 115. So if I do 160 minus 115, that gives me 45. Divide that by 3, tells me that sigma is equal to 15. So there we go. That's already going to cut out B, D, and E as possible answers. So all I've got to do now is find my mean. How do I do that? Well, I now know that each gap is 15. So I can now do 160 minus 15 gives me 145. Yeah, I just know that that gap there is 15. So 145 gives question 9C as my correct answer. Oscar walked for 9 consecutive days. The time in minutes that Oscar spent walking on each day is shown in the table below. A least squares line is fitted to the data. The equation of this line predicts that on day 10, the time Oscar spends walking will be the same as the time. So I now know from that question that they are giving me an indication that days go along the bottom and time goes, because they're predicting the time, right? Equation of line predicts the time. So knowing that, and again, I'm not going to put this on my CAS calculator because it's just going to blow out the length of this video. Hopefully you know how to do a regression analysis. If not, tell me and I'll do what I can to provide an additional solution. But what I did was when I put this into my calculator, I got T was equal to 44 minus 1 times the day number. All right, so those were my 44 minus 1 times the day number. So because it now wants me to predict day 10, I did 44 times 1. Sorry, try that one again. Let's try that one again. 44 minus 1 times 10, which gives me 34. So what I had to do then was look at what day was the same as 34, and it was day 4. So I reckon B was the correct answer. Question 11, the table below shows the weight in kilos and the height in centimeters of 10 adults. Okie dokie. A least squares line is fitted to the table. The least squares line enables adults' weight to be predicted from their height. There we go, height and weight. The number of times that the predicted value of an adult's weight is greater than the actual value of their weight is. Now, when we have a line of best fit, if you remember, we will have our points either above the line or below the line. So the number of times that the predicted value of an adult's weight is greater. So what they're really saying is how many points fall below our line. This one I will do on my calculator, and I can only show you the TI Inspire. And there we go. I've now put my data in. Fingers crossed it's all correct. So I go a menu. No, I don't. What I then did, he said, was I inserted a new document, data and statistics. Along the bottom, I put height. Up the side, I put weight. There we go. And then, well, this was certainly what I did then. I went menu, analyze, regression, and I said do A plus BX. And there we go, it put my line on. And to be honest with you, all I did there was count the points. 1, 2, 3, 4, 5, 6. So I counted 6 points, and so I posited that D was the correct answer. There was another way. I found this function, which was quite funky as well. I actually then did menu, analyze, and residuals. and then basically show residual plot. And again, it put my residual plot on the bottom there. 1, 2, 3, 4, 5, 6 of them are negative. If I remember from the Casio ClassPad, you can actually put the residuals on the data, which would have cut all of this out because you would have then just counted how many were negative. But I quite like the idea that you can actually see the residual plot on here as well. All right, so 6 was my correct answer. Time series plot below shows quarterly sales in thousands of dollars of a small business for the years 2010 to 2020. The time series plot is best described. And again, this is going to be one of those contentious ones. I think there's seasonal data because if you look, it tends to have some sort of seasonality to it, peaks and troughs in pretty much the same places. There are always irregular fluctuations in the time series diagram. Seasonality, it seems to be repeating every year, seasonality. And if we notice, we actually see that the data is tending, sorry, do it the way for the camera, to slope down. So as far as I'm concerned, if I was answering this as an exam, which I am, a decreasing trend with seasonality and irregular fluctuations, I would have put E as my correct answer there. And again, because it does say what is the best described. Time series plot below shows the points scored by a basketball team over 40 games. The 9 median smooth. I've never seen 9 median before, but it doesn't matter. It really shouldn't matter. Whether it's 3, 5, 7, 9 or 100. Well, maybe 100. The 9 median smooth for game 10. So there we go. So there's game 10. There's one of them. That means I now need 4 on the left and 4 on the right. 1, 2, 3, 4 on the left. 1, 2, 3, 4 on the right. So those are the 9 data points I'm going to look. Because it wants the median, you're going to start from the bottom and you're going to count up to the 5th data item again. That's right, because it's 9. The 5th data item is going to be the one in the middle. So 1, 2, 3, 4, and 5. So my 5th data item, and I read off the value 110. So again, I would suggest that C there would be my correct answer. A garden centre sells garden soil. I love this question, but again, to be honest with you, this is like more methods than anything, and don't quote me on that one. The garden centre sells garden soil. The table below shows the daily quantity of garden soil sold in cubic metres over a 1-week period. The 5 mean smooth quantity of garden soil sold on Thursday is 206. The 3 mean smooth on Thursday is, okay, so what I did here was I went, well, let's call that A, B, and C. So where we have a 5 mean smoothing, you add the 5 values together, 186 plus A plus B plus C plus 346, all divided by 5, because that's how you'd find the mean, is giving me 206. Okay, so then what I did was, right, well, I did a bit of rearrangement, and I ended up, he says, turning the page of his solutions, that gave me A plus B plus C was 498. Now, why is that useful to me? Because what it's then telling me is that these 3 values all add to 498. Why is that important to me? Well, because how would you then find the 3 mean smooth? You would add the values of A, B, and C together, and you divide by how many there were. Well, they've just told you that the values of A, B, and C added together is 498. So to find the mean of that, I would just divide by 3. And 498 divided by 3 gave me 166. Table below shows the number of visitors of an art gallery during the summer, autumn, winter, and spring quarters of the year. The quarterly average is shown in each of these years. Why would that be important to me? Because they're going to ask me to do seasonal indices, aren't they? Yes. The seasonal index for summer is closest to. Now, because they want summer, you have to find the seasonal indexes for 2017 summer, 2018 summer, and 2019 summer. Add them all together and divide, you average. Okay, so what I'm going to do is go back to my screen here and just show you how to do the first one. So this one here, if I wanted to find that seasonal index, I would do 29685, and I would divide that by my quarterly average of 27194. Hit enter. And once again, my CAS is in the wrong mode, and that gives me 1.096. So what I did there was write down all my values on my calculator, or not all of them, 1.0916, and I continued doing them for each of them. So the 2018, when I did that on my calculator, gave me 1.09647, and again, when I did the same for summer of 2019, it gave me 1.07704. Now, having got all of those values, what did you do? You then needed to average all of those. So you add them all together, divide by 3, which gave me 1.088. And so C was my correct answer. The number of visitors to a regional animal park is seasonal. Data is collected and deseasonalized before a least squares line is fitted. The equation of the least squares line is given by that. Right, okay, so what it then wanted me to do is find the actual number for February. Well, that's February. There is my seasonal index. So the first thing I need to do is find my deseasonalized value. How do I do that? I use my equation. So using the deseasonalized value, I know the monthly number is 20. So what I did was 2349 minus 198.5 times 2. And that gave me 1952. That's my deseasonalized. How do I go back to my original value? Well, I multiply that by the seasonal index. And again, these should all be formulas in your summary book. So if I multiply that 1 by 25, I get 2440, which gives me E as the correct answer. I will be honest, I forgot the formula. Originally, I divided it and got the wrong value and then felt very silly. Whoa, there we go. So that was the data and statistics done. I don't think that was too bad. My apologies if you're sitting there going, oh, you are a tosser. I don't mean that. Please don't be rude. By the way, like the video. Please like the video and subscribe. Turn off notifications from my channel. It just helps me know that you've watched the video. All right, we're going to move on to recursion and financial modeling. The following recursion relation can generate a list of numbers. The value of L2 is 37. So what we've got here is we have the first, so we've got L0, L1, L2. So we know that L0 is 37. We know that L2 is 25. And we know that to get to each of these, we are basically doing something with this value of C. I must be taking away two values because they're getting smaller. So what I did there was I did the difference of 37 minus 25, which gave me 12. And because I've got to reduce by two things to give me 12, I divided by 2, which gave me 6. But we had to be careful that it was negative 6, yeah, because we're taking away 6 each time. Deepa invests $500,000, can't even read, in an annuity that provides an annual payment of that. Interest is calculated annually. The first 5 lines of the amortization table are shown below. Okay. The principal reduction associated with payment number 3. So if we're trying to find the principal reduction, we're trying to find this, then basically I can just do that value there minus that value there. And again, to save calculator stuff, when I put that into my calculator, I got $27,008.15. So C would be the correct answer there. The number of years in total for which Deepa will receive the regular payments is closest to. Well, this to me was a financial solver question. And to be able to do that, I had to find my interest rate. So to find my annual interest rate, I did 20,000 divided by 500,000 times by 100, which gave me 4%. So how did that now help me? Right, well, if we bring up my financial solver, menu 8.1, N is what we're trying to find. The interest rate we said was 4. The principal value was minus 500,000. The payment we were giving was minus 44970.55. Our future value was going to be 0. Our payments per year were going to be, provide annual payments, so 111. So tab, 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 and go back to begin. And when I do N, silly mistake, what did I do there? I put a minus sign in the wrong place. So let's try that one again. Let's go back up and do that again. When we hit that, we get 15, all right? So, and I did that last night as well when I was doing my solutions, which is annoying. So B worked out to be my correct answer of 15. Whew, those minus signs, hey? Sammy purchased a boat for $72,000. The value of the boat is depreciated each year by 10% using a reducing balance method. In the third year, the boat will depreciate in value by 10% of. Well, what that's a trick is, they actually wanted you to find the value in the second year. So what I tend to do again is I put in my original value of 72,123, and then I just do my answer times, because it's reducing by 10%, my multiplier would be 0.912, gives me 58320, which gave me C, all right? Hopefully that didn't trick you. Enrico invests $3,000 in an account that pays interest compounding monthly. After 4 years, the balance of the account is that, the effective annual interest rate. Now, I watch that all the time now. Why? Because it's annoying. Okay, so how did I do this? He says, looking very quickly at his answers. Right, I tended to use the compound interest formula here. And I said that my final amount was 3728.92 is equal to my initial amount of 3,000 multiplied by 1 plus my rate over the number of compounding periods, which is 12, divided by 100 to the power of the number of payments. Because I've got 4 years, 4 times 12 gives me 48. And I quite literally put that in my calculator with a solve, comma R. And what came out was the R was 5.45%. Now what I've got to remember is that was monthly. I then went menu, finance, interest conversion, effective interest rate, and I put 5.45, comma, you've lost the comma sign, 12, because that's going to tell me my effective interest rate was 5.59%. So I would suggest D there was my correct answer. There are other ways of doing this. I think other people did it on the financial solver. Yeah, no. Joanna deposited 12,000 into an investment account, earning interest rate of 2.8% per annum, compounding monthly. She would like this account to reach a balance of 25,000 after 5 years. To achieve this balance, she make an extra payment to the account each month immediately after the interest is calculated. Okay, so we go back to the financial solver, menu 8.1. Right, what do we want? She deposited 12,000 into the account, so she's paying, which she's not very happy about. 12,000 the principal, oh, that was interesting. Try that one again. So we'll put minus 12,000 in there maybe, yeah? There we go. The payment is what we're trying to find. The future value, the account would like to read 25,123. Payments per year, she's compounding monthly. So that should have automatically worked. The number of payments, well, 5 years. So 5 times 12 gives me, and the interest rate was 2.8%. So fingers crossed now, if I go to my payment, he says, and hit enter, $174.11. Ka-ching. And again, with this one, it's always about those minus signs. BL has a reducing balance loan. The balance in dollars of the loan from month to month BN is modeled by the accounts relationship there. Given that the loan will be fully repaid in 20 years. Again, I like this question because you're like, is this a financial solver question? And actually it turns out it really is. Here is my payment. Here is my initial value. We're going to try and find the interest. We've got the number of years. So what I did there was I said, what was it? Interest is paid from month to month. Model balance in dollars from month to month. Okay, so first thing is 20 times 12, which gave me 240. Interest is what we're trying to find. The principal value is how much the loan was, 450,123. The payment we now know is 2633 because we've read that. Sorry, make that minus. He's going to pay it off, so that's going to be 0. And generally speaking, those values stay the same. So when I hit I, we get my interest rate. Now, again, we need to be careful here. My monthly interest rate then worked out to be 3.6%. So when I turn that into a yearly, so an annual one, I did 3.6 divided by, oops, try that one again. I did 3.6 divided by 12, gave me 0.3%. That's as a decimal, you're going to divide that by 100, which gives me 0.003. All right, and because it's a loan and it's interest, we need to add on the value of 1. Remember that 1 plus R, sorry, capital R is 1 plus little r over 100, which gave me 1.003. 23. There we go. Bob borrowed $400,000 to buy an apartment. The interest rate for this loan was 3.14% per annum compounding monthly. A scheduled monthly repayment was allowed Bob to... This question was awesome. Again, you may disagree. I'm so sorry. Because it was a bit of a trick. When you pay an interest-only loan, you're only paying the interest. Okay, so when you're paying an interest-only loan, you're paying the interest only. But the loan value doesn't change. And that was the trick here. So basically what they're saying is Bob borrowed 400,000 to buy an apartment. So 400, 1, 2, 3. The interest rate was 3.14%, 3.14% per annum compounding monthly. Okay. The scheduled monthly payment allowed Bob to fully repay the loan was determined. That was the trick, because what it's now saying is how many, I've forgotten, 20 years. So 20 times 12 again. It's going to pay it off. Right. So if I hit enter there, then what we actually find out is that the actual payment that Bob should have been making to reduce the balance of the loan was 2246.53, roughly, let's put a dollar sign there, 2,246, but he didn't. What it said was, for the first 2 years, he didn't pay anything but the interest, which meant the loan stayed as the same value. After these 2 years, the interest rate changed, and Bob was still able to pay off the loan in those 20 years, which really meant that he's actually got 18 years left. So if I do 18 times 12, all right, so 18 times 12, now he's making 216 payments, and it wants us then to find the interest rate, because he still owes that 400,000. He's only paid the interest, his principal is still the same. And when I hit enter, I get 2.21%, which thankfully is one of the answers. And that was the end of the financial section. Hopefully you guys did okay in this and didn't get too tricked. And moving on to the modules, I will start with matrices. All right, so matrices. Interesting exam. Right, question number 1. If matrix M is given by that, then it's transpose. When you transpose, what do? Rows becomes columns. There we go. So our row of 3, 2 becomes a column of 3, 2, row of 8, 9, column of 8, 9, row of 13, 7, column of 13, 7, as far as I'm concerned, gives me D as my correct answer. A nice question there. Every Friday, the same number of workers from a large office building regularly purchase their lunch from one of 2 locations, the deli or the cafe. It's been found that of the workers who purchase lunch from the deli one Friday, they will return to purchase from the deli the next Friday. So what we're looking for now is this Friday to next Friday, D to D being 0.65. So it can't be that one. All right, there we go. So that was it. So what was it? Friday, this Friday to next Friday, deli to deli, 65%, 0.65. Now again, what do we know about the columns? They must add to make 1. So we're now looking to make sure that anything with a 0.65 in adds to 1. Well, that certainly doesn't add to 1, and that certainly doesn't add to 1. So we've narrowed that down already to just those 2 answers, or 2 suggestions. Of the workers who purchased lunch from the cafe on Friday, 55% will return next Friday. So cafe to cafe needs to be 0.55, and as far as I'm concerned, there we go. D would be my correct answer. The set of simultaneous equations does not have a unique solution. All right, so when it doesn't have a unique solution, the way I do this is by teaching the matrices, and I know that the value of A times B minus the value of try that one again. Yeah. So you just do the opposite corners. Opposite corners multiply, subtract them, minus 4 times 18. Now for it not to have a unique solution, that has to equal 0. Now basically that's the determinant. And if I was to write this out the long way, you may have been taught to write A for 18B, X, Y equals 10, 6. All right, and then I always teach my guys to make sure that they then know how to find the determinant. It's those 2 corners multiplied together minus those 2 corners multiplied together, and for it to not have a unique solution, that has to equal 0. So when I then did this, that gave me the value of AB had to equal 72. Now you don't have any other information to help you find the values of A and B, so what you now need to do is go through all of these individual questions and find out which of those 2 multiply to give 72, and as it turned out, it was only A. All right, tricky question, but there we go. For Ramon and Norma are names that contain the same letters. The permutation matrix can change that into that is. Right, so what we now look at is when we look at a permutation matrix, look at this. What that's saying is the first element of the new matrix will equal the fifth number, or the fifth thing in the original, right? So basically what we're saying here is that when I multiply this, does n come first? And it does, because our last value here is n. Does it go first? It does. So what we need, using a process of elimination, is a 1 to be in that number there. So that discounts C. Let's look at the next one. So the next one says that the second thing in my new one is going to be equal to the first of my old one. So the second in my new one is going to be the first. Well, that's not true of A. What do we do here? The second of my new one, so we've got O. So we're going to go, the fourth one is going to become the second. Yep, so the fourth one is going to become the second, has to have a 1 here. So that's possible, that's possible, that's possible. Okay, so we've still got 3 possibilities. And what I did was just work through each of those using exactly the same logic. I discounted B, I ended up discounting D, and giving me E as my correct answer. A is a 7 by 7 matrix, B is a 10 by 7 matrix. Which of the following matrix is defined? Now remember, for it to be defined, you've got to have the rows and columns when you multiply things. So I always say, you know, the outside of the first and the inside of the second have to be the same. So if I look at AB, so if I just look at this one here, AB, I have a 7 by 7 and I have a 10 by 7. Well, for a start, those values there are not defined. They're not the same, so we can't do that multiplication. So A is automatically off. So what about B times A? Can we do B times A? Well, B times A will be then 10 times 7 and 7 by 7. We can indeed. Marvelous. So BA is defined, but remember, if we are going to then raise it to the power of -1, that's finding the inverse. And you can only find inverses of square matrices. Well, although those are the same, these two here are different, so that's not going to give me an answer of a square matrix. So again, B cannot be done. What about A times B squared? Well, again, you can only square a matrix, i.e. times it by itself. So B squared is the same as B times B. Well, what would we have there? A 10 by 7 and a 10 by 7. So again, no, that's not possible. A squared, can we do that? Well, we now know that we can do A squared because we've got a 7 by 7 multiplied by a 7 by 7. That's going to work. And then we're going to minus BA. Well, when we do BA, what do we do? B times A is going to give me a 10 by 7. And is that going to be possible? No, because this here is going to give me a 7 by 7 as a result, but I can't take away a 10 by 7. They have to be the same order to be able to do that. And so by a process of elimination, it turned out that E was my correct answer. The fitness center offers 4 different exercise classes: aerobics, box fit, cardio and dance. A customer chooses. Choice of fitness class is expected to change from week to week. All right, so when we got this transition matrix, they drew a diagram and all they put on was that 25%. So we had to then go, well, okay, what letters go on each of these corners? Well, for 25% going from 1 to a 1, there was thankfully only one of these values that was 25%. It was that one there. So first week to next week, B to D. So I now know automatically that that had to be B and that had to be D. Awesome. What were we trying to find? The value of W. All right. So we now had 20% going from one thing to another. And we look on our table and we're like, oh, hold on a moment. That's annoying because we actually have two 20% between C and A or A and C. So we could have A here and C here. That was certainly one of the choices. But then what I had to look at and say was there a root between D and C? Was there a transition matrix between D and C? And when I looked at that, there was actually 0 going between D and C, no connection. So what I said was, okay, well, that's the wrong way around. So let's put C there and A there, and can that well work? Is there a D to A? There is. So D to A is 0.1. So D to A, that was gives me 0.1. And so A to D was 0.15. Now remember, that 0.15 is actually just a multiplier. It's a decimal value of a percentage. And so I suggest that B there would be my correct answer. Okay guys, welcome to this question. This matrix is determined by using a recurrence relationship where you've been given T, S0 and S1. You've got to find C and then S2. All right, so we now know from using this information that S1 is going to be equal to my transition matrix times S0 minus some value of C. Now they've given me what S1 is. It's 24, 54.3 and 20.7. So what I'm now going to do is my transition matrix times S0, which actually I've already done there. So when I do my transition matrix on the calculator times S0, what I get is 27, 53.3 and 22.7. And I'm going to minus some value of C to get there. So 27 minus something gives me 24. So that's got to be 3. 53.3 minus something gives me 54.3. Because it's getting bigger, I have to minus 1. And then I've got 22.7 gets to 20.7, so I'm actually going to subtract 2. So there we go. So that's my value of C. What do I do now? Well, I'm going to go back and I'll say, well, I now know that my next value to get to S2, I'm going to take my transition matrix and multiply it by S1. Well, we know that S1 is given by, no, where have you gone? Come down, come back. 24, 54.3, and 20.7. And then what I'm going to do is subtract from that my new value of C, or my value of C, which is 3 minus 1 and 2. And hit enter. And there we go. 23.04, 55.78, and 16.1A. Ka-ching, A, my correct answer. A new colony of endangered marsupials is established on a remote island. For 1 week, the marsupials can feed from only one of the 3 feeding stations at A, B, C. On Monday, 50% of the marsupials were observed feeding, 50% at B. Okay, so what I now know is I've got this. So I've got 50%, 50%, and 0 at A, B, and C. That's my S0, as it were. So that actually stands for Monday. According to the question, that stands for Monday. The matrix determining to get to the next one, blah, 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 blah. From Tuesday to Wednesday, the percentage of marsupials who are not expected to change their feeding locations is. All right, this is the way I did it. All right, so there's my transition matrix in, and I am now going to multiply that by, he says, all right, so what am I going to put in there? 50, 50, and 0. So when I do that, that gives me Tuesday. So the percentage who are at Tuesday would be 25, 35, and 40. Okay, and Wednesday is going to be, well, actually, I don't know that I need to work out the Wednesday, because it says from Tuesday to Wednesday, the percentage of marsupials who are not expected to change. So from Tuesday to Wednesday. Well, if I look at my not change, that's 0.4, 0.5, and 0.6. So A going to A, 40% of what is already there isn't going to change. So I did 0.4, that's 40% of the 25% that is there, plus 50% of the 35, because those are the percentages that are already there. So 50% of those aren't going to change, and 60% of the 40% is not going to change. So when I put that onto my calculator, just checking I got the same as I put on my working out, I actually got 51.5%. Now I'm going to be honest with you, I got a feeling I've been tricked on that question, all right, because a colleague of mine got 50%. But I'm going to go with D at this moment in time. If you disagree, let me know by leaving a comment below. Moving on to the second module, networks and decision mathematics. All right, consider the graph below for question number 1. The number of vertices with a degree of 3 is 1, 2, 3, 1, 2, 3, 1, 2, 3. That's got 2, that's got 3, that's got 3, and 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 of those have a 3 on them. So I'm going to suggest E as being the correct answer. 5 friends ate fruit for morning tea. The bipartite graph shows below which type of fruit each friend ate. Which of these are not true? Only Lee ate a pear. Well, only Lee ate a pear. That's true, so that's no good. Eric and Kai each eat an apple. So again, if I look at this, Eric and Kai each eat an apple. That's actually true, so that's no use to me. Van only ate a strawberry. Well, he didn't. He ate a strawberry and an orange. So that's, oh, hold on a moment. That's not true. That's the one. That's the one. So actually, I'm going to circle that at the moment. And obviously, it'd be always a good idea just to check the others. Quinn and Kai each ate a banana. Quinn and Kai, they did. So that's not true. Or that is true, and so not true. I don't know what I'm saying. Orange was the most eaten type of food. It was, because 3 people ate an orange. So no, C is my correct answer. Correct. I've got a, oh. Anyway, consider the graph below. The number of faces is, it's a trick. Why is it a trick? Because for it to be planar, you can't have something crossing. So I'm going to move this line here over here. So that gives me 1 face, 2 faces, 3 faces, and 4 faces. So I think C is 4. Question number 4 I thought was funky. Let me see. The number of vertices that cannot be reached from X. So let's have a see. We can get to W from X. We can get to Z from X. We can get to U from X. Where else can we get to? Can we get to Y from X? Yep. Can we get to V from X? Yep. And in fact, the only one we can't get to is S. And the reason is basically because if you look at it, there's no way to get into S. There's only 2 ways to get out. So the number of vertices that cannot be reached, I suggested, was 1. Consider the following 5 statements about the graph above. All right, this again was another interesting question. The graph is planar. Well, for it to be planar, we use very fat elephants. So I used V plus F minus E equals 2. The vertices were 3. The faces were 3. Sorry, the vertices were 6. The faces were 3. The edges were 7. That gave me 2. So the graph was planar. The graph contains a cycle. Okay. So reading the definition, a cycle is a path where there's no repeated edges and no repeated vertices that start and ends at the same vertex. All right, so I'm going to say that one again. He's lost his pen. A cycle is a path, no repeated edges, no repeated vertices that starts and ends at the same vertex. Well, as far as I'm concerned, while you can get down here, you can't get back. So you're not allowed to repeat edges or vertices. So that can't be true. The graph contains a bridge. All right, so there is a bridge, because again, reading this, a bridge is an edge in a connected graph that, if removed, will cause the graph to be disconnected. Right? Well, if we took away that one there, then basically, that dot would be disconnected. So the graph contains a bridge. It does. The graph contains an Eulerian trail. So the definition of an Eulerian trail is it is connected, which it is, has exactly 2 vertices with an odd degree. The graph contains an Eulerian trail, has exactly 2 vertices with an odd degree. I don't believe that's true. And a Hamiltonian path visits every vertex of a graph. Okay, so a Hamiltonian path visits every vertex. And I can do that. There is one of those. So as far as I'm concerned for question number 5, consider the following 5 statements about how many are true. I would say 3 were true. And again, I'm just going to check the Eulerian trail again. I'm reading the description. It follows every edge of a graph, and the Eulerian trail will exist if the graph is connected, has exactly 2 vertices that have an odd degree. I'm just going to check that's only got 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1. So there seem to be 4 edges there that have odd degrees. An Eulerian circuit, that would actually have an Eulerian circuit, because an Eulerian circuit says have vertices. Nope, that's not true either. So I'm going to go with 3 with that question. The directed graph below shows the sequence of activities requested to complete a project. The time taken to complete each activity in hours is also shown. The minimum completion time for the project is 18 hours. Maximum value of X is. Okay, so what I'm going to do now is I'm going to draw my boxes on. Now I do this differently from the Cambridge textbook, and I tend to put them on the edges, not the vertices. The reason being is because my float times seem to always work when I do it this way. When I've done it on the edges, it all gets very confusing. Here we go. So they have to start at 0, so they become zeros. Now G would have to start at 4 because C is going to take 4 to complete. and F would have to start at 7, and I would have to start at 7, simply because 4 plus the 3 gives me 7. So those have to start at 7. Let's work my way along here. That's got to be 3. That's got to be 9. That's also got to be 0, by the way. Now, by the time we get to this point here, I've got a choice, and I have to choose the largest value. So I've either got 7 plus 1, which is 8, or 4, 5, 6, 7 plus 1 is 8. Yep, and that's going to be 0 plus 5 is 5. So I'm going to put an 8 in here. 7. So again, I've now got a choice by the time we get to here. So that's going to be 9 plus 2, which is 11. E I'm going to leave for the moment. 7 plus 4, which is 11 as well. 11 plus the 7 gives me, so that's got to be 11. 11 plus the 4 gives me the 18, and ka-ching, I've got my way through. So how does that help me now? Well, basically, the earliest start time of E is 8 there. The earliest start time of J is 11. So if I do the two of those take away, if I do 8 minus 11, I get 3. So I'm going to suggest that C was my correct answer for question 6. The network below shows the pathways between 5 buildings J, K, L, M, and N. The adjacency matrix for the network is formed. The number of zeros in this matrix is, and again, this took some time to do. So having drawn that up, let's have a look. J to J. Are there any ways of going from J to J? J back to J? Nope. So that's a 0. That's as far as I'm concerned. J to K. Well, J to K, you can go 2 ways. You can go that way, or you can go that way. So I put a 2 there. J to L. Again, as far as I'm concerned, J to L, there was only one way in which to be able to do that. J to M, there is no direct path from J to M, so that was 0. And J to N, there was 1. And what I know is that my rows become columns as well. So I just copied that down as 2, 1, 0, 1, and then I continue. So K to K, let's delete all of this for a moment. Are there any ways of getting from K to K? Well, yes, I can go from here to here. So as far as I'm concerned, that was 1. And I just wanted to check there, because if I remember rightly, a loop counts as 1 edge. All right, so 1 edge, but 2 degrees. So it doesn't matter which way I go around that. There's one way of doing it. So I placed a 1 here. K to L, there are 2 ways. I can go this way, or I can go that way. So there's 2 ways. K to M, there's only 1 direct route. And K to N, I put a 0. And again, I just copied those down as 2, 1, and 0. Now to complete the rest of my diagram, I got 0, 1, 1 there. And 0, 0, and 0, and 0. So when I count the number of zeros, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I think C is my correct answer. A network of roads connecting towns in an Alpine region is shown below. The distance between the neighbouring towns represented by the vertices is given in kilometres. The region receives a large snowfall. Now basically this was a shortest path, and I used Prim's algorithm, and so try and work this out, he says, trying to flip to his notes. Just bear with me. All right, I always start at that point there. So I got the smallest gave me 42. So coming off of there, what do I have? Well, I have a 29. So I'm going to count that as a 29. Now, the reason I didn't look at any of my values of x's at the moment, because it said the x value could either be 50 or 55. So the question I'm looking at here tells me that x is either going to be a value of 50 or 55. Well, it doesn't really matter which of those for the moment is the right one, because I've got a shortest path I can climb off of. So then I said the next one was 30. And then I got to a point where, okay, so now I have to choose x as my next value, because x is either 50 or 55. So the chances are, because I want it to be the shortest path, I don't want it to be 55, because I could have chosen that top one there. So I said, well, okay, let's now make x 50, which meant that I chose x as my next value. Right, where do I go next? 50. So coming off of there, 22 is my shortest. And again, y is either going to be 60 or 55. And here we go. So then I said, right, where do we go next? 40 with my next smallest one. Then I had 36. And then I had 52. And so now, realistically speaking, I've got a choice, 60 or 55. Now, you could have chosen 60, okay, or 55, but the trick to the question here was it actually wanted the shortest distance to be 361. So what I then did was I took all of my paths together and I did 42 plus 29 plus 30 plus 50. I'm just working around my diagram. Plus 22 plus 40 plus 36 plus 52. So those are the ones I already had highlighted, which gave me 301. Well, bearing in mind it's now got to add up to 361, then that would suggest that y would have to be 60, which gave me B as my correct answer. Module 3, Geometry and Measurement. I really like this one. I believe there were some really nice questions in this one. Geometry and Measurement. Which of the following cities is closest to the Greenwich Meridian? Well, we know that the Greenwich Meridian is 0 degrees. So there was east and there was west. If I look at I'm looking for the one that's basically, I'm not interested in the north or the south. I'm only looking for the one that's closest to 0. And as it turned out, Loam there was the closest to 0. And if I've mispronounced that, I am so very sorry. A clock displays the time 1 o'clock, as shown in the diagram. The angle theta between the small hand and the large hand is, well, we know that there are 360 degrees in a circle. And basically this is an hour. So there are 12 hours. And when I do that, I get 30 degrees, which gave me C as my correct answer for question 2. A photograph was enlarged by an area scale factor of 9. Now, the minute they told me the area scale factor was 9, I know that my length scale factor is the square root of that, which is 3. So I know the lengths are actually 3 times bigger, because remember, length times length gives me the area. The length of the original photo was 12 centimeters. The original photo and large photo are similar in shape. That tells me that I can use this rule. The length of the enlarged photo in centimeters is, well, it's 3 times bigger than 12, which gives me 36 centimeters. This question was funky, and you could have done it in a number of different ways. It's a very good question to say what they were. But first things first, I know that the area of that triangle, when you're given that, is basically you can have a half AB sine C. And we know that the angles in the triangle or equilateral triangle are 60 degrees. So that became a half times 4 times 4 times the sine of 60. And bearing in mind it was not a correct solution, D was wrong. And again, they're trying to trick you, because that can be written as 4 squared on 2 times the sine of 60 degrees. What else? E was basically Heron's formula. So if you know what Heron's formula is, that exactly was the same answer. Now, to be honest with you, what I probably would have done is I would have worked out the value of this on my calculator, and then I would have tested all the other values to see basically which one isn't correct. Because what turns out to not be correct is C, because that's basically a half base times height. And that's not possible because we don't have a height there. So it was in fact C was the incorrect answer. B and A are all being tricky because they all sort of come off from this formula here, believe it or not, just written in different ways. If you're doing methods, you would have known that, because you would have known to be able to find the height, and you would have had surds and all sorts of stuff. But anyway, there we go, C. A cone and a cylinder both have a radius r centimeters. The height of the cone is 12. So I've got a cone, and I know that's 12, and it's got a radius of r. And the cylinder, so what we've got here, we've got a cylinder, also has a radius of r, height of a cylinder. I actually call the height of the cylinder x. The reason being is they have the same volume. Now the volume of a cylinder is given by pi r squared times x in this situation. So it's pi r squared times the height, and I've called the height x. A cone is 1/3 base area, which is a circle, which is pi r squared, times the height, which is 12. Now, the great thing here is that using a little bit of algebra, we can cancel those out because they effectively are on both sides. That gives me that x is the value of 1/3 of 12, and 1/3 of 12 gives me 4. So question 5A is the correct answer. Question 6 was funky. Now, what I tended to do here was go, well, okay, I'm going to now imagine that as a rectangle. All right, so I'm going to cut that circle in half, because if I can think of that as a rectangle, then life is good. So that gives me that the radius of that there is actually half of this 6, which is 3. So I now have a rectangle that's actually 21 by 6. And inside of that, I have 3.5 circles. So I worked out the area of the rectangle, which was 21 times 6. And then I took away the area of a circle, which was pi times the radius squared. And I then said, well, I've got 3.5 of those circles. So when I do 21 times 6 minus pi times 9 times 3.5, what I actually got was the value of 27. It was closest to 27, so B was my correct answer. Question number 7, I was looking online for what people thought their answers were, because I know that on Reddit you guys will tend to rush around and put your answers on. I have to say, I don't agree with the answers people put on there. So I'm just going to work it through my way, and if I've made a mistake, then I will hang my head in shame. I know that I can find this angle here. How? Well, it's an equilateral triangle. No, it's not. It's an isosceles triangle. So I now know that these two angles here would be 180 degrees minus the value of A. And to find one of those angles, I just divide it by 2. So if I do 180 minus A, that is going to give me this angle here. But I know there's another way of finding that angle there, because it is 180 degrees minus the value of B. So when I multiply those together, or when I multiply this out, I get 180 minus A. I'm going to times both sides by 2 effectively, which gets that divided by 2 goes. Gives me 360 minus 2B. All right, so I'm going to take away 180 degrees from both sides. Gives me minus A is 180 degrees minus 2B. Now what I can actually do there is multiply everything through by minus 1, or give me A is equal to minus 180 plus 2B, or A is equal to 2B minus 180 degrees. Oh, actually, that's D as my correct answer. Rod and Lucia went on a bushwalk. They walked 1,400 meters from the car park to reach a lookout before... Anyway, this was a long question. So let's work this one out together. So I've got... Let's draw my diagram first. There's my diagram. I've got my car park and my lookout. So the beach of the swimming pool, so the bearing of the swimming pool from the lookout is 290 degrees. So the swimming pool I'm going to put here. The bearing of the cafe is 240 degrees, and I'm going to put the cafe here somewhere. The swimming hole is closer to the lookout than it is the car park. Again, I don't fully understand what that's telling me. So I've got basically this diagram here. All right, so how does that help me? So the bearing of the swimming pool is, no, we noticed that one there is 1,400. Sorry, I'm just talking to myself, it would appear. The cafe is 700 meters from the car park. So that was the cafe. So that's 700 meters. And the swimming hole, nope, not interested in that. The swimming hole is 950 meters from the car park. Okay. Right, so what do we do here? So we also know that we've got bearings. So what did it say? So the bearing of the cafe from the lookout is 240 degrees. The cafe from the lookout is 240 degrees. And we know that from the lookout to the swim pool, it was 270 degrees. I know that's 70 degrees, which tells me that the angle inside here is going to be 20 degrees. So that angle there is 20 degrees. What else can I do here? Well, I know that from all the way there to there is 240 degrees. So I'm going to do 240 degrees. So if I do 360 minus 240 minus 90, it gives me 30 degrees. So that angle there is 30 degrees. How is that going to help me? Well, we're trying to find in total, in the relation to the total distance, each of them walked individually from the lookout back to the car park. So we've got to find this length plus this length, or that length plus that length, and see what happens. All right, so let's do that individually. All right, let's see what we do here. We have to do a sine rule. So I'm going to find that dot angle first. So what have we got? 950 over the sine of 20 is going to equal to 1400 over the sine of the dot. Let's just do that for this moment in time. All right, why am I going to do this? Because I'm then going to be able to find this distance here using the sine rule again. So when I put that into my calculator, I actually get two values. And so I get 30 and 149.73. Well, actually, it makes sense for that angle there not to be 30 degrees. It's about 149.73 degrees. So I'm going to rub that out and put 149.73 degrees. That would suggest that I can now find this angle here as by doing 180 minus 20 minus 149.73. Hit enter gives me 10.27 degrees. So that there is 10.27 degrees. How is that going to help me? Well, I can now use sine rule again to say that 950 on the sine of 20 equals x divided by the sine of 10.27. So solve. 950 divided by the sine of 20 equals x divided by the sine of 10.27. Hit enter. Oops, don't forget to do comma x. Gives me 495.21. So that means that this distance here, 495, he says, writing 2, 495.21 meters. So that's that one. Now let's do the same here. Oh, what do we know? So the lookout, the bearing of the swimming pool, the cafe is 700 meters from the car park. All right, so again, let's see whether we can work out this length here. How are we going to do that? So we got 700 over the sine of 30 equals, finding this angle here, is going to give me 1400 over the sine of the dot again. All right, so let's see if we can find out that. So I'm going to solve again. 700 divided by the sine of 30 equals 1400 divided by the sine of x, comma x, and I only want values between 0 and x. 180 degrees basically gives me 90 degrees. There we go. That's nice. Finally, something nice. So that's 90 degrees there. So that would give me 60 degrees here. Cool. So basically, just to continue in the same theme, I may as well do the same. 700 divided by the sine of 30 is now equal to x on the sine of 60. So let's do that. So we'll do sine again of 700 on the sine of 30 equals x on the sine of 60. Oops. Comma x. Oh, I've done sine. Solve. Let's try that one again. 700 root 3. Let's get that to 1212.43. Okay, so let's now go down to the options. He says, Rod and Lucia walk the same distance. So let's just see. If we add those, so if we do 950 plus 495.21, gives me that we've got 1445.21. So that was, who walked that way? Rod returned to car park via the cafe, Lucia via the swimming pool. So that's Lucia. So Rod will be 1212.43, oops, 1212.43 plus 700 gives me 1912.43. All right, so Rod walked 467 kilometers further. Let's do that. Minus that, it gives me 467. Let's just see. Rod walked 467 meters further than Lucia to the nearest meter. Rod walked 17 further. Nope. Lucia walked that further. Nope. Nope. Phew, that was a lot of work for 1 mark. I can see why people have just gone, I've just guessed that one. All right, so there we go. B, as far as I'm concerned, correct answer. All right, graphs and relations module, last module of the exam. Question number 1. The graph below shows the average number of sunlight hours per day for each month of a particular year. Okay, thank you. The number of months for which the average number of sunlight hours per day was recorded as being below 4. Well, there's 4. So we want basically 1, 2, 3. B was my correct answer. Which of the following represents the line with the same slope? When it's the same slope, it's the same gradient. And luckily they wrote it in a really nice form there, so the gradient is equal to 2. So what we're going to try and do is rearrange these equations so that we can get y on its own and see which one has the 2. So if I rearrange this, I get y is equal to 2x, and basically, ladies and gentlemen, A was the correct answer. But just to show you, if I did B, for example, you get y is equal to minus 2x. Well, that value there and that value there aren't the same, so it's not B. Y equals 3x plus 2. Well, that number there is a 3, so that's no good. The next one would be y equals minus 2x plus 3. Again, minus 2, no good. And when you rearrange E, same. A line passes through the points 8, 0, 0, 6 and 5m. The value of m is... Okay, so I worked out the gradient between these 2 points. So I know the gradient between those two is y2, which is 6 minus y1. So again, y2 is 6 minus y1 over 0 minus 8. 0 minus 8, which gives me 6 on minus 8, which gives me minus 3 on 4. Now, what we also know is the gradient between these 2 points is exactly the same as well. So I just did the same working out. So I said m minus 6 on 5 minus 0 equals, and it's the same gradient, so it must equal minus 3/4. Now in this situation, probably not very wise of me to use m, so let's use that as gradient, for example, because they use m in the question. So we end up with m minus 6 on 5 equals minus 3/4, and if you wanted to, you could have just solved that. Let's just do that on my calculator. Solve, what is it, m minus 6 on 5 equals minus 3 on 4, comma, m, hit m, we get 9 on 4. That wasn't one of my suggestions, so 2.25 gave me D as my correct answer. A railway station in the city has 2 car parks east and north. Or the fees for East Park is low, and the North only wants to park a car for 7 hours on Wednesday and 4 on Thursday. So this is what I did. I went, okay, so she's got Wednesday for 7, Thursday for 4, and we had the choice of North and East, I think it was. North Park and East. I'm actually going to write it the other way around just because I've done all the working already. So East and North. So what I actually did there was just work out the cheapest, or how much car parking cost in each of those sections. So for the North Park, all right, it was $2.30 times the number of hours. So $2.30 times 7 for Wednesday gave me $16.10. And then $2.30 times 4 hours gave me $9.20. Now really what I'm trying to do is find the cheapest car parking option on each of those days. East Car Park was just looking it up. So 7 hours is going to give me $14, right? Because between 6 and 10 hours, she's going to pay $14. And for 4 hours, she's going to pay $10. So then I said, was okay, what was the cheapest to park in on a Thursday? Well, the cheapest would have been at the North Car Park. What was the cheapest on a Wednesday? That would have been the East Car Park. And so when you add those two values together, when you do 14 plus $9.20, you get $23.20. So I suggested C was my correct answer. A manufacturer makes and sells heaters. The fixed cost to manufacture the heaters is $16,000 a month. $16,000 per month. Each heater costs $52 to produce, and the selling price is $280. So the selling price, so a profit, all right, for one heater is going to be equal to $280 minus $52, which I think I wrote on my calculator as $228, right? So that's the profit. But obviously he's got this $16,000 he's got to pay for. So when I did 16,000 divided by 228, that gave me 70.17 ... Well, that's his break-even point. So his break-even point, he's got to sell 70.17 heaters. You're not going to sell 0.17 of a heater. So to make a profit, he's got to sell more than that. So I reckon the correct answer was 71 heaters. The graph below shows the relationship between 1 on x and y. The rule that represents this, okay, well again, because it's a straight line, we can use y equals mx plus c. Now the y is y, so that's fine. My gradient I'll find in a moment, but my x-axis was actually 1 on x. Now my gradient is easy to find because they gave me a point, and if you remember, it is rise over run, so that's 2 on 5, so my gradient is 2 on 5, and the intercept here is actually 0, give or take. So when we multiply those together, I get y is equal to 2 on 5x, and so I suggested that D would be the correct answer for that question there. Almost at the end of this paper, a couple more questions to do. The feasible region for a linear programming problem is shaded in the diagram below. Which objective function z will not have a maximum value? Now, for that to be true, I always use the sliding line. And what do we do here? So what I said here was, when we have a look at this equation, then we get, when we rearrange it, and I always rearrange it for y equals, I get y is equal to minus x plus z. So now, using my sliding line, I'm looking for a gradient of minus 1. So a gradient of minus 1, I can draw a line between 40 and 40, for example, and now I can just drag that up. And if it hits only 1 point, then that will be the maximum, and so A wouldn't be my correct answer. So in that situation, A wouldn't be my correct answer. B, let's rearrange that one there. So I've got 3y would be equal to minus x plus z. So y would be equal to minus 1/3 x plus z on 3. Again, I'm just looking for the gradient of minus 1/3. So that means for a rise of 1, we have a run of 3. So a rise of 10, a run of 30. So what I'm now going to go is go 10. Oops, he says. I'm going to go from 10 to 30. There we go. There's my straight line, roughly speaking. Now, when I drag that around, what do I notice? Oops. That when it hits K, it actually will go through other points. All right? So in that situation there, that's no good to me. Which objective function will not have a maximum value? I think, as far as I'm concerned, B was the correct answer. Because when I tested all of those others using the sliding line, then basically they all just went out of the graph and just touched K. So the gradient there worked for me. A company produces 2 types of tennis rackets. I won't read the rest of the question. The graph below shows the lines that represent the boundaries of these inequalities. So the feasible region, basically, if I remember rightly, he says, not missing that altogether, is this section here. So there's my feasible region, all right? Thank you very much. The profit P that the company can make each week from the sale of these tennis rackets is in the form of P equals AX plus BY. The maximum profit will occur when 20 smash rackets and 40. So I know now that X is 20 and Y is equal to 40. All right, the maximum profit will occur, if A equals 15, the maximum profit is. Okay, so first things first, I need to find the equation of my profit function. All right, so profit is equal AX. So A is 15, so I get 15X plus BY. And again, as I've done previously, I always rearrange this. So I get Y is equal to minus 15X. BY is equal minus 15X plus P. So Y is equal to minus 15 on B times X plus P on B. Right, well, because that point lies on my maximum profit function, or it lies on a line, then I can actually find the value of B, because the gradient of that line there must equal the gradient of this line here. Okay, so we know the gradient of that is equal to minus 50 on 100, which is minus a half. So therefore, we know that minus 15 on B is equal to minus a half. The minus signs cancel, so B becomes equal to 30. Well, now that I know B is 30, my profit function now becomes equal to 15X plus 30Y. How is that useful to me? Because I now can find the maximum profit by putting the values of 20 and 40 into there. So when I did 15 times 20, plus 30 times 40. I ended up with 1500 and E as my correct answer. Whew, there we go. Those are the solutions. Thank you very much for watching. Please like, please subscribe. Again, turn off notifications. I just would like to know that people are watching these and let your mates know that the solutions are here. My name's Darren, Maths Guru. I look forward to seeing you in another video. Take care, guys. Bye-bye.